If we have a locomotive on the track, then the positive rail, the red rail, will be on the right of the locomotive for it to move forwards. So red rail on the right, black rail on the left, the locomotive will move in that direction. We don't have to apply solder to this now because both the rail and the wire are tinned. It's just a question of getting them both to melt.
And you've got a nice shiny joint there, so that's going to be fine.
And the advantage of doing it under the rail is that when I put that wire down through the baseboard, as you can see, the wire is very stiff, so once it's in position it's not going to move anywhere.
And more importantly, you can't actually see it, so it's not obtrusive, and because you soldered that way you haven't melted any of the sleepers, you'd hardly know it was there.
And that's all there is to it.
So if you think of these things, the operating concepts early on, you can actually make a layout that's got a lot of operating potential right at the outset.
Yes. Quite often you will find that once you start operating a layout, you will think of other things that you would like to have done. You can just add extra sections or change them around to suit yourself. But when you're initially starting to plan the layout, thinking about the electrics at an early stage helps not only with doing the electrics, but it helps refine the operating plan as well. The track plan has the feeds marked on them, where we agreed that we needed feeds, and it's got the insulated brakes marked on. I've added numbers for each of the feeds so that we can identify the wires. The wires have gone under the baseboard and would normally run to a terminal block under the baseboard. But for the sake of making it easier for us to demonstrate, this one's on top. And as you can see, each of these wires has a label on which gives its number. So this one's got 3 on, and relating that to the track plan, I can see that that wire comes from the feed over here. In with the solder, watch it flow, out with the soldering iron and the wipe. That's a good connection. If you give them too much electricity, if you leave it running rather than just give them a pulse, it will start to burn out the wire on the coils. You get this smell of burning, and then you have a point motor that doesn't work anymore. So ideally we need a device that will provide a big kick but a very short one, and that device is called a capacitor discharge unit. It would be rather nice if we converted the sidings into a loop that reverses round so we can drive straight back into the terminus.
That's a great idea, but aren't there problems with reversing loops?
Of course there are problems with reversing loops, but fortunately we can fix them.
And do you need one of those per locomotive, or will this drive several locomotives?
This will drive as many locomotives as you have, but you do need one per operator. But I could operate 2 locomotives at once. For example, I could set one going round the oval of track and then switch to shunting in the terminus using the same handset. Could also use them to operate the points if we wired the points up for DCC.
So you can control the whole of the layout, any number of locomotives from here.
The only thing that these can't control are our reversing loop switch. If we were going for a full DCC conversion, you can buy special units that do that automatically so that you don't have to think about it.
But if we go to the other side of switch number 1, the lamp lights up. So we've got our 12 volts there, we just don't have it on the other side of the switch. This tells us then there's something wrong with the switch. Either the wiring around the switch, something's possibly dropped off the switch, or the switch itself could be faulty. Check that out, replace the switch if necessary, and everything will be fine.